Want to see something cool?
Want some bite size? Yum!
Welcome to Bite Size, a YouTube channel for the National Museum of Nuclear Science and History, where every experiment and every demonstration has a difficulty rating so you know you can do these at home. Have you ever seen a really cool video or demonstration or experiment on the internet, and you get all these materials, you get ready, you go to do this experiment, and you realize, wow, that is way harder than it looked. Or you're like, that's just not nearly as cool as it was in the video. Every video we do in our Bite Size series will have a difficulty rating in the video's description. That way you're gonna know before you start the project just how involved this thing is. Whether it's a project that you say, oh no, I got a science fair tomorrow, or it's something like, I want to do something huge and elaborate and show my friends, you're gonna know how expensive, how difficult, and how likely to succeed that video is before you get started. I'm Mr. Dave, and for our first installment of Bite Size, we're gonna do something with a whole lot of wow and very little difficulty. We're gonna make a laser microscope. Our difficulty rating for this project, where 1 is like a candle and 5 is like Superman's laser vision, this one here would probably be a 1.2. So it's right about like a flashlight with the batteries dying. This is a very easy project. This is something you can have a very short and quick setup time, and it's very inexpensive. You can do this whole project for under $5. It rarely ever fails, and it looks great. All right, here we are in the spooky dark, and we have our materials ready for our laser microscope. What we have is a laser pointer. This is just a small laser from the dollar store. It only cost $1. We have a small ball of modeling clay. We're gonna use this to stabilize our laser because we don't want a lot of movement there, because every little movement with our laser is gonna result in a large movement with our projection. We also have a syringe. Inside of this syringe is water from our cat's dish. So we're gonna magnify with our laser everything in a tiny drop of water. See that little drop? We're gonna use that like a lens. That drop of water is gonna refract the laser and is going to use that laser and project it on this big surface here. But before we do, we're gonna kill the lights. All right, so this is actually our projection from our laser microscope. This is everything that you're seeing that's actually inside of that little bitty drop of water. All of this is about a 2-foot area onto our blank wall behind us. So it's a nice big magnification of everything in that tiny droplet. We can see little bitty microorganisms. We can see microparticles. We can see just general floaties that are all in that little drop. So when your laser shoots through the drop, it's refracted, and that light is spread to a big area on the wall here, and that's what's enabling us to see a magnification of everything in that drop. All right, so you saw all of the gross things in that water. Now we're gonna show you how to do it. You're gonna take your laser, you're gonna set it in your clay, and you do that so that it kind of stays still. It's a little bit easier to move around, okay? And then you're going to take that laser. If you start higher with your beam, if you start higher up on this syringe, you're gonna have an easier time tracing it down to that droplet of water. Now, when we do it with the lights on, you're not gonna see a whole lot of projection down here. That's why we did that in the dark, but we're gonna show you how we got that, okay? So, you'll take your laser, you'll start high up on that syringe. Okay, you see that dot way up there? And then you're just gonna trace that laser down, and you can see as it's going down that syringe, if you watch the syringe until you hit the droplet, then you look at your screen, you're gonna have a lot easier time. Now here in the light, you really don't see too much when it gets to that droplet because it's all refracted, and that laser is actually spread out in this huge area right here. So it's gone from what is a little bitty dot to taking up this whole area because that lens has spread that light out. And it works just like a microscope, or just like a magnifying glass, or just like a telescope. They all work by taking the light and bending that light. So the light's been bent to where it's taking up this whole area here, and that's how you see all of those little yucky worms and life and things that were in that little drop of water from your cat's dish. Thanks for watching our video about laser microscopes. We are the National Museum of Nuclear Science and History. I'm Mr. Dave. Please like and subscribe.